Wing Marine is proud to introduce a groundbreaking dredging system specifically designed to maintain ports, harbors, channels, and reservoirs. With its unique features and capabilities, this system is set to revolutionize the dredging industry. Standardized operating procedures and common mechanical systems are joined to create an extraction system that will accomplish many tasks. This flexibility combines with the high effectiveness and key features of the system to support commercial competitiveness and associated growth potential. Our sediment extraction system uses two vessels, each supporting a unique tool. The first vessel supports the wing, a tool that creates a controlled sediment wave effectively moving over 1,000 cubic yards per hour of material to a collection area. The second vessel uses a powerful submersible pump that extracts over 500 cubic yards of sediment per hour to the surface for disposal. Ports and harbors must maintain the required water depths. The Wing Marine's goal is to minimize the downtime for berth and channel depth maintenance. A typical berth regularly involves the removal of up to 6,000 cubic yards of material. Wing Marine would excavate a sediment collection area using the pump vessel. This could be done while a ship is docked at the berth. When the berth is free, the wing vessel would sweep the sediment into the collection area in less than 6 hours, and the pump vessel could start removing the sediment to either a hopper barge or by pipeline to the disposal area. With container port fees currently exceeding $100,000 per day, this fast maintenance turnaround could minimize port losses and maximize berth availability. Mechanical and cutter suction dredges often face issues with buried metal debris entangling their mechanism, stopping dredging for hours and days. The Wing Marine system uses a unique method to overcome this challenge. The system blows the sediment around the debris without slowing the work, and the pump has guards preventing large debris from being ingested. The debris will fall to the new bottom for later retrieval by a dive team if required. Our process for maintenance of general-purpose berths is identical to that of container berths. Minor differences are water depth and worksite characteristics, which are both addressed in our standard extraction methodology. Reservoir remediation is a growing field that requires practical solutions to manage sediment accumulation behind dams, which is crucial for maintaining reservoir capacity, flood control, and dam longevity. The Wing Marine system operates in water depths up to 180 feet and features a modular design for easy access and relocation. Its extraction pumps transport sediment into a half-mile pipeline with booster pumps facilitating longer distance movement to the final disposal area. The shallow draft of the Wing Marine vessels makes them ideal for maintenance of barge channels such as the U.S. Intracoastal Waterway. Disused pipelines and cable crossings often require removal or repair due to corrosion or redevelopment. The wing fluidizer was developed to expose these structures for installation, maintenance, and repair, and to restore the site for offshore projects. Shoals can obstruct shipping channels in riverine and estuarine and tidal areas, especially after storms. The Wing Marine system can remove or dispose of shoal material in deeper waters. Removing sediment around the hull is crucial to its recovery when a large vessel is grounded. Wing Marine vessels use pumps to clear the sediment and the fluidizer to quickly create a channel for towing the ship to deeper water. In beach nourishment, materials are sprayed directly onto the shore. The wing helps move sediment close to the beach while the pump vessel sprays it further ashore, operating effectively in sheltered waters. The fluidizer, when deployed from an open water vessel, prepares a trench for installation of subsea pipeline or cable and for restoration of the right-of-way. Additional uses for the system include blowing sediment off shellfish beds and supporting marine archaeology. The vessels are designed as modular components that can be assembled or disassembled in 4 days. This innovative design allows each vessel to be quickly transported to remote locations, deployed for emergencies, or shipped internationally. The road transportation of each vessel requires 10 48-foot flatbed trailers along with a 60-ton mobile crane to assist with the assembly and disassembly process. 3 primary vessel configurations are anticipated. They are the fluidizer vessel, the single pump boat, and the more powerful dual pump boat configuration. Diesel-electric systems power the vessels. Each vessel has a captain, an operator, and a deckhand. The hulls are identical in size and fabricated from commercially available modular pontoons. They're propelled by specially designed azimuthal thrusters, which allow for an operational speed of 1 to 2 knots and a transit speed of over 6 knots. The wing fluidizer vessel supports the fluidizer, which utilizes a proven design to create a sediment wave capable of transporting large quantities of sediment across the sea or lake bed. 4 cables launch, suspend, and control the attitude of the fluidizer from extendable davits. This 4-point suspension system allows for vertical control during the deployment and recovery of the fluidizer, as well as adjustments to its distance from the bottom and angle of attack. The fluidizer measures 25 feet in width and employs contra-rotating tunnel thrusters that apply low-pressure water to fluidize the sediment. The vessel's movement generates a sediment wave in the desired direction. The fluidizer relies solely on the power of water to move sediment and never touches the seabed. The water pressure exerted by the thrusters is approximately 3 pounds per square inch, ensuring that the operation does not damage any underwater objects or harm aquatic life. The operator monitors the sediment density wave and adjusts the fluidizer to optimize the amount of sediment moved during each pass. This unit can effectively transport sediment without relying on water currents or sloping bottoms, moving materials in any direction. The extraction pump vessel utilizes an A-frame to deploy the pump, which is suspended from 2 cables. This design minimizes pump torque during both startup and operation. The pump can produce a slurry that contains between 40% and 70% sediment and can extract rocks and solids up to 10 inches in size. The cables control the pump's depth, while sediment discharge monitoring ensures that the density remains within a specified range. The vessel gradually moves over the sediment collection area, continuously removing sediment. The discharge hoses are those recommended by the pump manufacturer and are flexible enough to meet our requirements. Compared to empirical data for cutter suction dredges, the Wing Marine system demonstrates a strong performance. Wing Marine extraction pumps operate with sediment concentrations ranging from 40% to 70% in the extracted slurry. In contrast, conventional suction cutter dredges typically produce slurries containing only 15% to 25% sediment. The dual-pump vessel offers considerable increase to system output without sacrificing system performance at restricted sites. A comparison chart illustrates the extraction capabilities of both systems using average sediment solids densities of 55% for the Wing Marine system and 20% for the cutter suction dredges. This analysis indicates that a single 12-inch Wing Marine pump can extract the same volume of sediment as an 18-inch suction cutter dredge. Furthermore, 2 12-inch Wing Marine pumps are projected to extract an equivalent volume of sediment to a 27-inch suction cutter dredge. Wing Marine was established in 2020 to develop a concept that utilizes proven components to execute dredging operations. The small, agile vessels provide a platform for working in all areas of ports, harbors, channels, and reservoirs with minimal impact on other shipping. Small size allows this robust system to be used worldwide. The Wing Marine system has secured patents in the U.S. and in Europe. Its uniqueness lies in the innovative use of existing technology, providing an alternative dredging method to the market. The cost of producing these vessels is significantly lower than that of a cutter suction dredge, while offering comparable dredging capacity. Additionally, the operating costs are much more economical. This represents an exciting new entry into the world market. If you're interested in investing in Wing Marine or want to be considered a potential client for our system, please contact us.